AB Calculus Note Card 10, Derivative Rules, Power Rule. This is the 10th video lesson in the series of the Note Card system developed by Stacy McMullen, formerly of the Dallas Independent School District. These are the basic derivative rules. And so these are the rules that will enable us to do what we did sort of the long way in Note Card 9, the definition of a derivative. So we're going to go over these rules here. d dx, which means the derivative with respect to the variable x of c, and c being a constant c, is going to be equal to 0. So the derivative of any constant is 0. 2, the power rule, which might be the single most used technique in calculus. Derivative with respect to x of a variable to a power equals that power times the variable to the power of the original exponent power minus 1. The constant multiple rule, if you have the derivative of something that is multiplied out front by a constant, you just multiply that constant out front. Very intuitive. Likewise, sum and difference rule. So we're going to go over examples of these here right now. If f of x equals x to the 3/2 power, then f prime of 4 equals. Well, what this is f prime of x is going to be equal to derivative with respect to x of the original function here. Okay, so that's how you could write that and explain what that is. And so d dx, according to the power rule, I'm going to write over here, d dx with respect to x of x to the power of n equals n times x to the power of n minus 1. So we're going to use this rule here. And so f prime of x, in this case, we're going to take that value of n, 3/2, and multiply it by n to the power of, I said n, I meant to say x. 3/2 x to the power of, we're going to have this n value of 3/2 minus 1, which is going to be 3/2 minus 2/2, which equals 1/2. So we have x to the 1/2, and f prime of x equals 3/2, and x to the 1/2 power, that's an exponent in rational form. We're going to rewrite x to the 1/2 power as the square root of x in radical form, and now we can just substitute in 4, so f prime of 4 is equal to 3/2 of the square root of 4, which equals 3/2 times the square root of 4, which is 2. There we go. So f prime of 4 is equal to 3. Okay. Next, for 2 and 3, differentiate each function. And again, we have a function that is in radical form. In order to use the power rule, it's necessary to change a radical form into a rational form, and f of x is going to be equal to, we have 1/2, and this, we have a cube root of x squared, so that's going to be x to the power of negative 2/3. Okay, so that's just what we call a calculus-friendly rewrite And now below, we're going to find f prime of x. So f prime of x equals to, we're going to take this negative 2/3, which is the power, and multiply it by 1/2. Okay, so that was our n. We multiplied by n, and we have x to the power of, well, negative 2/3. We're going to subtract 1, and subtracting 1 is going to be the same as subtracting 3/3. So we're going to get to the power of negative 5/3. So x to the negative 5/3. And rewriting this and simplifying, well, 2/2 will cancel. So we're going to have negative 1 in the numerator, and this 3 will come down to the denominator. We have 3, and x to the negative 5/3 power is going to be cube root of, in the denominator, x to the 5th. So this is going to be our answer for f prime of x, right here. Okay, next, a of t, differentiate. So we're going to obtain a, we call a prime of t, and we're going to use the power rule, and I'm going to change this over 2 to 1/2, and then we have actually negative 1/2, because that's going to be negative t to the 4th power, and then we just take that power of 4 and multiply it here, and we're going to have t to the power of 4 minus 1, which is 3. Then we have plus 3, I'm just going to write 3, which is the power, times this 3, t to the, what is 3 minus 1? 2. And minus 2, and we have t to what power here? That's to the 1st power. That's going to be times 1. And then we have t to the 0 power. Well, t to the 0 power simplifies to 1. So we're just going to simplify everything out here. I hope you can see that there's a lot of simplifying that can be done. So we have, here, we have negative 1/2 of 4, so that's going to simplify to negative 2, t to the 3rd power, and then we have plus 3 times 3, which is 9, and we have t squared, and then minus 2 times 1, and t to the 0 power is 1, so we have minus 2. So this will be our answer for problem 3. And finally, problem 4, d dx. Well, for d dx, is the derivative with respect to x, it's going to be like a function being f prime of x is equal to, what is 1 over x to the 3rd power? Well, it's going to be x to the negative 3 power. Again, calculus-friendly form, minus 1 over x, that's x to the negative 1 power, and then we have plus x squared. And now, I said f prime of x. It's wrong. That's going to be f of x. F prime of x is going to be our first derivative of this function we defined as f of x, d dx of that. So we're going to take this negative 3, the power out front, times x to the, what's negative 3 minus 1 will be negative 4. And for the next one we have minus, we're going to take this net power of negative 1 minus negative 1 to the power times x to the power of, what's negative 1 minus 1? Negative 2. And then we have plus, we have this 2 times, because that's the power, 2 times x, and we have x to the power of 2 minus 1, which is 1. So now we're going to rewrite this as f prime of x equals, we have negative 3 over x to the fourth power. And then negative times negative is positive, so we have plus, we have 1 over x squared, and then we have plus 2x. And finally, f prime of negative 1 is going to be negative 3 over negative 1 to the fourth power plus 1 over negative 1 squared plus 2 times negative 1. So f prime of negative 1 is going to be negative 3 over negative 1 to the fourth power. Negative 1 to the fourth power is 1. So then negative 3 plus 1 minus 2. So we're going to get negative 4. So negative 4 will be this expression here, ddx of this expression at x equals negative 1. So that's our answer. Now if you go back to note card 9, you might remember we had this function that f of x equals negative 5x plus 4. Do you remember that? Well, f prime of x, using the power rule, is going to be simply negative 5. And if you go back to note card 9, you'll see this power rule being much, much easier. So you kind of look at this as a much easier way and faster way to do what we looked at in note card 9 in the definition of derivative. Good luck, and thanks for viewing. Okay.